This is the floating metal experiment. You're going to see why it's called that, surprisingly. What you're going to need is some cooking oil. As you can see, I've got some cooking oil here, and I've just poured some into my little egg cup to make it easier for me to use it. You're going to need some metal, and I'm going to use a needle for this, a sewing needle I recommend. You see I've got one here. Now I've got a little pack of several sizes, but I'm just going to use that one right now. You need some tissue. Now you can see here I've got a square of kitchen towel, which I took from here, and I've cut a little square out, which is here. Okay, so that's what that was for. And I'm going to use 2 forks as well. Now I may not need to use these, but I'll keep them here just in case. What I'm first going to do is take my needle and I want to cover it in cooking oil. Okay, so I'm going to dip it in, give it a little stir, dip it in, and obviously I'm going to get a little bit on my fingers, but that's okay. I'm going to take it out, turn it around, and get the ending. So I get a good coating of cooking oil. Okay, so hopefully you can see that. Then I'm going to lay it very carefully onto the paper towel. Okay. Then I'm going to pick up the paper towel and as carefully as I can lay it on the surface of the water in the tray you can see. Now I'm going to get my forks, it looks like I'm going to need them. I'm going to push the tissue out of the way, or at least that's what I want you to do first. So hopefully you saw what mine did. You'll notice I didn't even use the forks after all, but remember I did tell you I may not need them. When I floated it on, the tissue actually got soaked with water and dropped away on its own under its own weight and left the metal needle floating on the surface. And I think you can see that doing that beautifully right now. So now you know that metal can float. So how can metal float on water? It doesn't normally float as a lump of metal, does it? Is it because it's just so small, it's so light? Well, no, actually, I can sink that, and I'll do it for you in a minute. Or I'll give you a way of doing it, actually. It will sink. I've got to be honest, it's not really floating in the way, say, if you've got a wooden block and put it in water, that floats. Or a boat floats, or you float actually, as you know, if you go swimming you can just float on the surface. You are floating, you are partly submerged in the water, and the water is holding you up because your body isn't quite as dense as the water that you're floating in. That's why you float. That metal, that needle is definitely far more dense than the water, and if we just pushed it a little bit further into the water it would actually sink. The reason it's resting on the surface, and I think you can see in the picture you've seen earlier, that needle is pushing into the surface and making a little dent there. It's pushing it down. And what's actually happening is the water is resting on the surface layer the water has formed. And on the surface layer of water you get what we call a meniscus. It's where the water meets the air. And it behaves in a rather interesting way. It pulls in all directions. That's why we say it has surface tension. Now some of you have heard it probably referred to as surface tension. That's really what it can do, not what it is. So it has surface tension and it has some strength. And some things, particularly if they're very, very small and don't weigh very much, like a needle, if you gently lower them on, as we did here, the tissue paper you saw went straight through, no problem. But the needle is actually not even in the water, it's resting on that surface and pushing down and making a little dent as it rests on. One of the reasons it's resting on so easily is because of the cooking oil. Do you remember I dipped it in the cooking oil? Oil repels water, okay? So when I covered it in oil, that oil is pushing the water away, and that's one of the reasons it's helping it to float. But to be honest, one thing you could try is doing it without the oil, and I'll leave you to do that, see what happens. I know it works very well when it has oil on it, as you can see. So what sort of things could you vary or change to see what's going to happen? Well, remember, I've got a little pack of needles here of different sizes. The obvious thing, you could try different size needles, couldn't you? Is there a difference? What about the biggest needle you can find? That's not the biggest one, no, it's the biggest here, but you can get a lot bigger than that. Maybe see if you can find the biggest needle possible and do the same experiment. Will it still work? What about trying something in the water as well, such as washing up liquid? Maybe get a bit on your finger or on the end of a pencil and dip it nearby and see what it does. Okay. I wonder what happened if we changed the temperature of the water. One thing I didn't mention, this water is just ordinary cold water, room temperature by now. I wonder what happened if we made it very hot. Not too hot that you can't touch it, so make sure you can put your fingers in it, but make it as hot as you can bear and try it with hot water. Do you think it would make any differences? What about freezing cold water, of course? Go the other way. Freezing cold water, what will that do? And I'm sure you can think of one or two other things.